Lesson 9.2 Part B. I'm just going to finish up the lesson. It won't take too long. And what we're doing is we are factoring first because we have two trinomials here in this rational expression. Again, rational expression meaning rational is fraction, expression is no equal sign. So we've figured out that we cannot cancel as is because of the implied parentheses. They are implied and we cannot affect one thing without affecting another when it's like this. So we factor. And if we factor, now we're going to have k factors of 35 that add up to a negative 12. That would be 7 and 5. And we need both negatives. On the bottom we have k and factors of 21, that's negative 21 actually, that gives us a negative 4. That'd be 7 and 3. And you have to get a negative 21, so one of them has to be negative. And we have a negative 4, so the bigger number should be negative. Negative 7 plus 3 is negative 4. Now that we have created this multiplication of two binomials, we can cancel. So x minus 7, x minus 7. So your answer will be k minus 5 I hate running with my mouse. Okay. Equals k plus 3. My airliner does not want to work for me. I don't need the parentheses here, but I see I just put them in. So, but k minus 5 over k plus 3. Now what are the excluded values? Well, we go to the original fraction and look at the denominator and say what could cause this to be 0. And that would be a positive 7 and a negative 3. So it's a lot like finding our x-intercepts for quadratics. Same mentality and purpose here. But 7 and negative 3 would cause the denominator to be 0, which would cause it to be undefined, unacceptable. So our answer's there and our excluded values there. Next one. Here we have a little bit messier situation, but let's take a look at that. They all have an m in common. I'm looking at the numerator first. And they all look like they're divisible by 10. So I'm going to take out a 10 and an m. If I do that, I have 3m squared minus, I took away a 10, I divide by 10 and divide by m, so just minus m minus, I divided by 10, so 14. Alright, so the bottom looks like I can take out a 10 again and an m, and that leaves me with a 5m squared minus 4m minus 1. Divide that by 10m, so that should be 1. Now this is the fraction. I could cancel out the 10m's at this point, but let's look at the trinomials and see if they are factorable. So if we look at the trinomials left, we have 10. Let's look at this separately here actually. I'm going to go over here and say if I have 3m squared minus m minus 14, I have a product of a negative 42 that needs a sum of, and again this is what I'm doing, 3 times negative 14 is negative 42. That's my product. I need a sum of negative 1. Okay. So that would be 7 and 6, where the 7 is negative. Okay, so going back to my problem here, that means I can factor that down to 3m squared minus 7m plus 6m minus 14. The first two have an m in common, and I get 3m minus 7 if I factor that out. The other one has a positive 2, so if I factor that out, I get a 3m minus 7. I now have a 3m minus 7 in common, and I'm left with an m plus 2. Okay, that's factoring by grouping. Alright, so that will be left aside. Now the bottom one, I have to do that one next, and that one has a product of 5 times negative 1, so negative 5 product, with a sum of negative 4, so that would be 5 and 1, where the 5 is negative and the 1 is positive. Okay, so if I write that down, go to the next one, so I have 5m squared minus 4m minus 1, and I rewrite that as 5m squared minus 5m plus 1m minus 1. I then take out a 5m in parentheses, and I get m minus 1. And then I will just take a 1 out of the next one, so I can just have m minus 1 in parentheses, which means I now have an m minus 1 in common and a 5m plus 1 left. Alright, so that means this one here becomes a 3m minus 7. Oops, can't forget my 10m. My 10m, parentheses, 3m minus 7, m plus 2, all over 10m, parentheses, m minus 1, 5m plus 1. A lot of review for our factoring, so you're going to have to, again, definitely brush up and practice it. Now what's that do for us? Well, it means now we can cancel. I can now cancel my 10m's out. I can now cancel, well, it looks like nothing else does cancel. That's too bad. Usually when you factor the next point, something might just cancel. Like we saw, nothing here it does, but it's a very good step to do. So really all that's left is this piece. Now if we're going to go back and decide what our excluded values are, our excluded values would be in the original, right here before we cancel anything out, when it's in factored, complete factored form. So m cannot be 0, m cannot be 1, and m cannot be a negative 1, and don't forget, divide by 5. So those are our 3 excluded values. Okay. Opposites. Alright, let's take a look at this one. So in looking at this one, we should recognize that if I rewrote this, I would get a negative. So let's rewrite that, and sorry for the interruption there. We would get negative t squared plus 36 all over 5t minus 30, and that's okay. I could factor the bottom one. Oops. I could factor the bottom one, but it wouldn't do me any good. The top one looks like a difference of 2 squares, but actually it's not yet. Well, it is, but it's not how we would factor it. So, but if I factor out a negative 1, then I would get t squared minus 36, which is a difference of 2 squares, and I can go ahead and factor that. Okay. It's alright. Alright, so let's factor it. The top one is the difference of two squares, so I have a negative parentheses. I have a t minus 6, a t plus 6. So remember how we factor a difference of two squares? Opposite signs and the square root of each one. The bottom one would be factoring out of a 5, and I get a t minus 6, and that is factored. Now, in factored form, we would ask ourselves, what were the excluded values? Let's do that first. What would cause the denominator to be 0? And the only thing here would be a positive 6. So that's the excluded value. Okay, and now can we cancel? Yes. Those two are gone, which leaves us with a negative t plus 6 all over 5. And again, if you distribute the negative or something, that's all fine too. But I would accept either one of these. There you go. Excluded value and solution, or factored, simplified form of a rational expression. Alright, so that ends lesson 9.